Hello everyone, myself N. Syed Muhammad Afsal. Today we are going to discuss about the topic support vector machine. Introduction. Support vector machine is one of the most popular supervised learning algorithm which is used for classification as well as recursion problems. The goal of SVM algorithm is to create the best line of decision boundary that can separate n-dimensional space into two classes so that we easily put new data point in the correct category in future. SVM choose extreme points vectors that help in creating hyperplane extreme classes or support vectors. Hence, algorithm is termed as supported vector machines. Logistic regressions versus support vector machines. Depending on number of feature, you have either choose logistic regression or SVM. SVM work best when the data set is small and complex. It is usually advisable to first use logistic regression and see how does it performs. If it fails to give good accuracy, you can go for SVM without any kernels. We will logistic regression and SVM without any kernel have similar performance, but depending on your future, one may more efficient than another. Types of support vector machines. There are two types of support vector machines. One is linear support vector machines and another one is non-linear support vector machines. Linear support vector machines. It is used for linearly separable data, which means if data set can be classified into two classes by using a single straight line, then such data is termed as linearly separable data, and the classifier is used as support vector machine classifiers. So as it is in 2D space, so by just using straight line we can easily separate these two classes, but there can be multiple line that can separate the classes. Non-linear support vector machines. It is used for non-linear separable data, means if a data set cannot be classified by straight lines, then such data is termed as non-linear data and classified using non-linear support vector machine classifier. Common types that are used in SVM. Support vectors, margins and hyperlines is the commonly used in SVM. Support vectors. These are the point that are closer to hyperlines. A separating line will be defined with the help of these data points. Margin. It is the distance between hyperline and observation closer to the hyperlines. In SVM, larger margin is considered as good margin. Hyperplane. This can be multiple line or decision boundary to segregate the classes in n-dimensional space, but we need to find out best decision boundary that help to classify the data point. The best boundary is known as hyperplane of SVM. The dimension of hyperplane depends on future present in dataset, which means if there is two future, then hyperplane will be straight line, and if there is three future, then the hyperplane will be in two-dimensional plane. We also create a hyperplane that maximum margin, which means the maximum distance between the data. Advantage. SVM is effective in high dimensional case. Its memory is efficient as it uses a subset of training points in the decision function called support vectors. Different kernel function can be specified for decision functions, and it's possible to specify custom kernels. Disadvantages. It is unsuitable a large data set and more complexities. Bad performance in high noise. Does not determine local optima. Thank you for listening the video.